Today I'm making a small intermediate connector for the CH341A eeprom programmer, and such that I can couple this as a mirror of that, but have an intermediate sort of jumper frame in the middle, so that I can reconfigure pins at will. And I've got a piece of variable. All this comes out my junk box, and I call it variable. It's a Chinese copy of variable, inferior to the original in that it's not as robust. So let's get on with it. I'm going to be a bit wasteful because I'm not sure how I'm going to arrange it. Now I use a drill about the width of the copper strip to cut through. Now I'm going to cut through 4 of them. So why this sort of sudden urge to do something like this? Well, I did have a question from on one of my other videos. How do I convert this to run on 5 volts only? I'm a bit puzzled. It was a 24C512, and as far as I can tell they will quite happily run on anything between 2.7 and 5.5 volts. So it should be programmable using one of these, providing you've got a correct software to drive it, and as programmer will program the 24C512. As programmer is a piece of software that drives this, and then it's a question of how you couple from here to the chip that you're programming. Some people have a lead and a clip, some people use dedicated connectors, component connectors, like I made one to do WSON 8 packages, which are particularly difficult to do without soldering. Works excellently, and I had a lot of them to do, so the time invested was well spent. My first option, piece of advice to anybody, would have been just buy a 24C512 that does work between 2.7 and 5.5 volts, and carry on using this as is. They're very common and sort of a pretty everyday item. Now, if you really must convert one of these to run on 5 volts, perhaps you've got sort of a dozen chips or so that you want to program. These are so cheap that it's worth making a dedicated 5 volt version, and to do that you'll just remove your voltage regulator and strap the 5 volts in to the 3.3 volts out, and you've got a dedicated 5 volt working device. End of story. There's a third option. Perhaps if it's a cable connector, to connect your wires here and break the cable somewhere and inject your 5 volts that way for the supply. Now, enough of all that. What I've decided to do, and I think it'd be handy for me, is to make a little universal breakout box, and that's what we're up to. I've got to ensure that these are sort of clear. You can use a small blade or a scalpel or whatever takes your fancy, needle file. Right, the object of this is to show you that you can do it with a minimal toolkit. Now, these will fit in like so, and that was the reason for breaking the tracks so that they don't short out with these pins. Right, next stage. Well, things must be getting serious. I've got my urine sample out again for flux, and I'm going to do some soldering. There we go. I'm not very good at this, by the way. My eyesight is not good. You may wonder what I'm up to. I'll just I have to carry on wondering. Hopefully that's done. Let's check it. Yeah, that's the pins that are going to go into the connector, like if it was open, like so, and that'll be held there like that. Next stage. First row of pins are going to be here. That's pin 8, and I want it to be in line with, that's going to be pin 8. That's going to be pin 1, that's going to be pin 8. So that's pin 8, that's pin 1. So pin 1's got to get from there to there, and we'll do that in a moment. In the meantime, let's solder this in. Try a bit of flux on it. I'm not so sure this board hasn't got a sort of a protective coating on it to stop it from tarnishing. I'll try something else in a minute. Okay. Right, so good, so good. So good so far. Get another row of pins in. These pins that are going in now will form the, these pins will form the cross connection, so we'll be able to couple like to like, or alternatively couple anything else we like onto these pins. So these are the outputs from from our CH341A. These will be pin 8, or pin 1 to pin 8, and we can cross couple directly across pin 1s to pin 8. Okay, pin 1, 2, 3, 4, 4, or we can jiggle them around to whatever combination we really want. Now that's the idea, and this will be over here somewhere, I hope. Yeah, it'll be there somewhere, I think. Right, worry about that later. Let's get on with this. Now, typically, as you might see what I mean about this track, it's broken already. That would never happen with proper variable. That would never happen with the years. This stuff is quite useless. Very, very fragile. And for this board, I need to move it to a good section. Further away than I wanted. Damn thing is getting bigger and bigger by the minute. Now, I'm finding this track lifting problem annoying, and if I bought any more board, I'd far rather pay out for better quality stuff if I can find it, because you do not know how frustrating this sort of track damage is. I think I've got a configuration that would work, so I'm going to solder this in now. It's surprising how much easier it is when you get things just about right. Now, one thing that's annoying me is the board's wobbling all over the place. You really need to hold it down somehow. If you do a lot of soldering, well, perhaps a fume extractor might be a good idea. Right, there we go. Basics done. Now I've got to break a lot of the tracks now to make it work. Let's get on and do that. I'm very much grabbing what I can find to sort of clean up here. Perhaps if we zoom in a little bit closer, and I just want to clean this up. This is not working for me, so rather than use a razor blade, I've put this over to one side, find something else. All I'm doing is showing that you don't need a bucket load of expensive Dremels and stuff to do this. Right, that's good. Well, we certainly need to break this line down here. There we go with our little drill. This Vero's horrible. Absolutely. Well, it's not Vero board. It's Chinese Vero board. It is absolutely built to a price. Awful stuff to use for prototyping. I'm not going to break any more tracks, although I have to do a few more. I think it'll become apparent what I've got to do as I start wiring this thing together. So far so good. It'll look a little bit like that, and our component adapter will slot in there. And our connections will go across here. Next job is to start wiring all the relevant pins to where I want them to go. I've had a short break, and now let's continue with doing the wiring. It seems a bit tedious, but we'll get there. Not good, but it will do. This is about as far as I can go today. I'm sort of progressing with the wiring. They're on their way home from being out shopping, so I better clear up and put the kettle on for them. We're back again, and another go at the wiring. I don't know how much free time I've got to carry on with this until they call me. Oops. But, I've got some different wires, really getting fed up with the other stuff. A bit of flux. Well, the tip I got on now is much more useful for soldering this one. I do keep a range of solder tips. We've done pins 1, 2, 3 and 4, which to go to 1, 2, 3, 4. This is 5, 6, 7, 8. So we've now got to, that's pin 8, so I want pin 8 to go to pin 8. So sounds convoluted, doesn't it? Pin 8 to pin 8. So I want, right, turn her over. Yeah, well, that's it. And I've got the wrong sort of tip on. You don't want a pointy tip when you're using the solder wick. You want a tip that's of similar width. So here and here, so that when you put your solder wick on, you can soak it up like a heat pad. Pointy tips it doesn't work well with. So now I've got one piece of track to repair between there and there, and I've got to break all those tracks between down along that side. I fancy resoldering that. Next job is to go and cut it to size. Well, this is it finished, the breakout connector. I've looped them all one for one. You can swap and change these around at will. I don't see why you would, but it allows you access to adapt for any sort of configuration you need. So if you're doing 24 series EPROMs, you stick it in the lower one of your CH341, like so. and if you're doing 25 series EPROMs, you stick it in the upper section like so. Now that means to say that the when it comes around to connecting an adapter for your EPROM to program, you just use the lower socket on the connector like so, and if it's a 24, as I said before, well, 25 in the top and 24 series in the bottom. That's how it's done. Let's leave it connected. There we go. That's it. I know some of you out there love these things. I hate them. They are horrible, and I have to be desperate to use one of these, and unfortunately there are circumstances where I do need to use a clip. Right, just find out where pin 1 is on my clip. Pin 1 is need something to point with. Pin 1 is that one there. Pin 1 to pin 1 in, clip, and you can fiddle about with these to your heart's consent. Why you would want to, I don't really know. If I had to resort to using a breakout connector, I would hardwire mine across to the requirements that I want, and do it that way. I don't like connectors. The inspiration for making this little breakout box for the CH341A MIDI programmer came from a comment in one of my other videos where a guy was having trouble programming a 24C512. He said that it was a 5-volt working only device, and that this wouldn't program it, and how could he convert one of these to work on 5 volts only. I question this because there was no other details, like what software he was using to drive this thing, or how he was connecting to the eeprom, whether it was a new eeprom or whether he was trying to reprogram an eeprom, and they all require slightly different techniques. The first option would be, common sense tells me, just to use a dual voltage working device, which most of the 24C512 range is. Now, if you're going to program a load of them and you need to convert one of these to 5 volts, the simplest option is to remove the little 3.3 5 volts to 3.3 voltage regulator and short the 5 volts to the 3.3 volt rail. That way you'll end up with a dedicated mini programmer for 5 volt devices. I think that's what I would tend to do. These are so cheap that if I had a particular job in hand where I had say half a dozen devices to do, that's probably and they only worked at 5 volts, that's the option that I would have probably gone for. Other than buying a dual voltage working, which seems a bit of a no-brainer to me. However, there are a lot of other reasons why you might want to modify one of these. You know, specifically the pinouts to the eeproms, or even get at the pins on the eeproms. So I came up with making this little header board. and I've got no use for it, but I may have a use for it, and that's why it's going into the toolbox. And I suspect that one day when I'm programming something, I'm going to go, oh, that's interesting, I'll grab that out and, you know, do something with it and see whether it'll help me in any way. Might be putting scope probes on or anything, I don't know. But I'll keep it in hand, keep it useful, and that's why I made it. Practically speaking, you're not going to need it. Just a last word I'd like to say about these things. I think they are absolutely awful. I hate them, but they are necessary to, in certain circumstances, when you're trying to reprogram an eeprom on board a laptop, for argument's sake. And I'll make another short video sometime about how to get the best results using one of these. To successfully program using the CH341A, you need to drive it with the appropriate software. Now, my favourite piece for programming the 24 series is AS Programmer, or AS Programmer. I'm not sure I've pronounced it properly. It runs on Windows, and that's why I keep a Windows operating system alive to run my, the odd program that I've come to love over the years. Other than that, I'm exclusively Linux based, although I do work on a few Macs occasionally. That's about it from me. I hope you found some of this interesting and inspire you to make your own. This is just a complete little bench job, knocked up in the afternoon and sort of made on the hoof. So they're not very difficult to make. You don't need a circuit diagram, you just need a bit of common sense. And good luck.